All right, this problem is really just a manipulation of Coulomb's law. So remember, Coulomb's law is F equals K Q QO over R squared. So if we look at the facts in this problem, it says two charges when combined give a total charge of 15 microcoulombs when the charges are separated by 4 meters. So 4 meters is your R. The force exerted by one on the other has a magnitude of 7.5 times 10 to the negative 3 newtons. So we have the force. Find the amount of each charge. So we know the force, we know the R, K is a constant, but we have two variables here. So the first line where it says two charges when combined give a total charge of 15 microcoulombs, that's what we're going to have to replace so that we have only one variable there. So what I'm going to do is, if the two added together equal 15 and I call one x, then what would the other one be? What's that? 15 minus x. And because it's in microcoulombs and I want it in coulombs, I'm going to have to write it as 15 times 10 to the minus 6. Now, let's see. I guess I'll put the units in here. So coulombs minus x. So if they give me the total, then I call one x and the other's the total minus that value. Because if I add them together, they will add up to 15 times 10 to the negative 6 coulombs. So now that I have that, the rest of it's a math problem. And actually, the problem with this one is that the math is going to be you're going to have to use the quadratic formula. So if I look at what I have here, I have F, R squared, and K. I'm going to get them all on one side because that's going to be my constant. In the formula, AX squared plus BX plus C equals 0, which is the generic standard form for a quadratic equation. The C is going to be the FR squared over K. And then I'm going to have this, I'm going to replace that with X, and that with 15 times 10 to the minus 6 coulombs minus X. So I'm going to have an X squared term and an X term just with the Q and the QO. So, so my next step is I'll bring the R squared over, and I'll bring the K over. And now I'm going to replace the Q and the QO, the Q with X and the QO with 15 times 10 to the negative 6 coulombs minus X. All right, any questions with that? So now, if I put this in standard form, my second degree term, my X squared term, is going to be, I have X times minus X. So X times minus X is minus X squared. I'm going to bring it over here. All right, so my first term is going to be X squared. Then I'm going to have X times that. That's going to be my BX term. So on the right side, it's a positive. So I'm going to bring it over here. And that's going to equal minus 15 times 10 to the negative 6 coulombs X. So that's my second term. And again, I brought both of them. Oh, great. All right, I brought both of these terms over to this side. So that one was already on that side. So my third term is going to be plus F R squared over K, and then since I moved everything to the left side, the right side is 0. Now what I'm going to do is I'm going to put what A, what B, and what C are in this problem. So I'm going to have my A. Again, what I'm trying to do is I'm trying to match up what the A is. So if I come over here, the A is 1. If I match up the B is negative 15 times 10 to the negative 6 coulomb. I have to bring the negative because there's a plus in the generic form. And then C is going to be that. Now I can get the whole answer right away so that I have a value for A, B, and C to plug in. So I will do that. So my A is going to equal 1. My B is going to equal negative 15 times 10 to the negative 6 coulombs. And my C is going to equal FR squared over K. And the units for this are actually going to be, what do you think the units are going to be for this final term? What do we expect X to be in? What are the units for X? Coulombs. So I'm going to have a coulomb times a coulomb, so that's coulomb squared. That's coulomb squared. So if that's coulomb squared and that's coulomb squared, I should get coulomb squared here. If I'm adding them all together, they should all have the same units. All right, so let's figure that out. So the F is going to be, what was the F? I don't remember. The F is 7.5 times 10 to the negative 3. The R is 4 meters. And that's squared. And the K is 9 times 10 to the 9th Newton meters squared per coulomb squared. So if you solve that, what do you get? Again, let's look at the units. We're going to get the Newton will cancel with the Newton. The meter squared will cancel with the meter squared. And I'm going to be left with coulomb squared in the denominator of a denominator. So I will get the units here for C in coulomb squared. And what do you get? One 1.32 times 10 to the negative 11 coulomb squared. So now that we know the A, the B, and the C, we can plug into the quadratic formula. The quadratic formula, I'll write it over here since I have some room. X equals minus B plus or minus the square root of B squared minus 4AC all over 2A. So that's your quadratic formula. And we know the values of A, B, and C. And our answer will end up being, we're going to get the answer in coulombs. So plugging in there. So our X is, our X is going to be one of the charges. If we go up to the top here, Q equals X. So it is going to give us the charge when we solve for X. And then whatever that value is, we put it in here and subtract it from 15 times 10 to the negative 6, that will be the other one. So let's see, putting that in, I'll solve for Q. So Q equals minus B plus or minus the square root of B squared minus 4AC all over 2A. And so for A, we're going to put in 1. For B, we're going to put in negative 15 times 10 to the negative 6 coulombs, there and there. What's that? No, the B itself is negative, but now I have a negative that is part of the formula, part of the quadratic formula, and then the fact, the B itself is a negative, right? And then C is 1.32 times 10 to the negative 11 coulombs squared. And if we solve that, now this is how I would put this in the calculator. I would start inside the square root and work my way out. There's a plus or minus, which might be the two choices that I get for the answer. So I'm going to get, if I put in the, I'm going to, since this is a scientific, since this number right here is in scientific notation, I'm going to put it in parentheses because I don't want my calculator thinking I'm just going to be squaring the 6. I want it squaring the whole thing here. The negative, I don't have to put the negative in because when you square a negative, it's still going to be a positive. So I'm going to put in my calculator, I'm going to open parentheses and go 15 EE negative 6, close parentheses, squared, minus 4 times, I can skip the 1. I don't really need parentheses here because I'm not squaring that 1.32 number, so I'm just going to put that in. 1.32 EE negative 11, and then I'm going to hit equals. And I get 1.722 times 10 to the negative 10 at this point. So that's what's underneath the square root. So if I want what that is, I'll hit square root of my answer. Square root of answer, and I get a small number, 0.000013122. So now I'm going to either make that plus or minus. So I think I will make that, well, let's see what happens if I make it plus. So I'm going to keep that, so that's my answer in my calculator. To that number, I'm going to add this right here. So I'm adding because minus minus makes a plus. So plus 15 EE negative 6 equals, and I have a number in my calculator, 0.0000281, and now divide that by 2. And I get, let me see, I want this number in scientific notation, so let me change this. Oops. Okay. Oh, I just messed up. All right, so I get here 1.41 times 10 to the, I didn't get inside, 1, 2, 3, 4, 5, times 10 to the negative 5 coulombs. So that's the answer if I use a plus. Now, if I use a minus, I should get the other answer. Bless you. And the two answers should add up to, so the other answer would be the Q, what I call the QO. And let's see, rather than me just subtracting it from 15 times 10 to the negative 6, because what if I did that, what if this first number is wrong? I want to check it by seeing if they do add up. So I'm going to clear the calculator and start over. So I'm going to have open parentheses, 15 EE. Actually, while I'm doing this, I'm going to shut off the podcast at this point because it's just math.